Well, this is the last problem on the practice exam, and I just want to review a little bit. So we have a parallel circuit connection. It's been a little while since we've looked at circuit stuff, so I just wanted to remind you. If we were to actually build this thing out of real parts, and I'm going to change the units on this just a little bit because there's one little thing here you haven't studied, which is this little kilo thing. I'm just going to cover that up. Just going to make those ohms there. Isn't that better? Well, it is for me. You don't care. So let's actually draw what this would look like using those circuit parts that we have. So I'd have my batteries hooked up like this. I'd probably jam 3 batteries in there. And, I'd have this little round thing here, like the little spring thing and the little um, connector there. So we've got the negative here and we've got the positive here. And what's going to end up happening is that our current's going to go like this. And the way we would actually hook up the light bulbs in this situation is that we'd have one light bulb. You know what? I'm going to actually be careful how I draw this. I don't like this wire that I drew. Let me get rid of that. So we're going to have, that was weird. Okay. We will have one wire like this. And I'm going to draw the light bulb part right here, like that. We'd have one light bulb here. And then what ends up happening is that we get a second light bulb here, connected like this. And then we'd have a third light bulb hooked up in sequence here. And the way this circuit actually works is that each of these light bulbs, if you disconnect one of these, the other two stay on and they stay as bright as they were before. So what ends up happening when you have a circuit like this is you have 1, 2, 3 light bulbs. They're all equally bright. And the other thing is that if you disconnect one of them, the bulbs don't dim at all, but they don't get brighter either. So you're at your maximum brightness for each bulb. And the price you pay for having all 3 of these light bulbs so bright is you end up draining your batteries a lot quicker this way. So our goal is to find the current coming out of the battery, and the rule for this is this light bulb takes on all the voltage of the batteries. It consumes all the voltage that's being put out by the batteries. So does this light bulb, and so does this one here. And this is what we call a parallel connection. So what this means is across this light bulb we have 9 volts, across this bulb we have 9 volts, and across this bulb we have 9 volts as well. And the rule is the current coming out of here, the total current, I'll call it I, equals the current going into this bulb here, plus this bulb here, and this bulb here. So we end up getting a total current coming out of the battery that's equal to the I1 here, the I2 here, and the I3 here. Current can be thought of as traffic, and each of these bulbs provides a lane for different cars to go down. So if I have, say, 100 cars here, I might have 30 cars here, 40 cars here, and 30 cars here. I like to think of current as kind of traffic, and I use cars as my analogy. So in other words, the total current is going to be I1 plus I2 plus I3, and our job is to break this problem down and get I for each branch. So I'll use the formula V equals IR, and in this case, for I1, that's going to be V equals I1 times R1, so 9 equals I1 times 10. So I1 ends up being 0.9 amps. Let's do I2 now. I2, V equals I2 times R2, so 9 equals I2 times 2. So I2 ends up being 4.5 amps. Finally, for I3, I have V equals I3 times R3. That's 9 equals I3 times 1. So I3 ends up being 9 amps of current. So let's add all this up. I total is going to equal 0.9 plus 4.5 plus 9 amps. So that's going to give me, let's see, 14, that 5, so 10, 14.4 amps of current coming out of the battery. So that's the last problem on the practice test, and I will have ready for you either Monday or Tuesday a second practice exam to help you get ready.